Okay, and we're back. It's a little after, well, closer to 7 now, but getting ready to pick up where I left off and finish off day 8. Had a little bit of time to think about the problem during the day, and I think I'm going to change up my strategy here a little bit, but not by much. Didn't really make sense to kind of do the calculation in decode. Um, I think I can probably just do it in the initialize method, uh, since there doesn't really seem to make sense to one have to run through the algorithm in decode every time, and also it's not really that useful a class without it having decoded the pattern. So I'm gonna move some of this elsewhere, and then segment decoder spec. Uh, we've got the signal patterns, and what we want to do is, so we've got the wire positions. So we're going to have wire positions as an object here, or as a instance variable. Get some noise here. Wire positions, and because of the API that I liked for 7-segment number from part 1 was something like this. Not part 1, part 2. 7-segment number. I wanted to be able to send it a hash with the position the segments are in, and then get the digit. But the thing about this is that I've got an array. I'm going to use an array to figure out what can go there. So I think I'll start. I think one. It doesn't really matter what I initialize it with, but I want to do. I'm going to call wire positions there at wire positions. I guess I might not even need to initialize it, but with anything, let's see if I need to. And then we'll call a private method of something like decode signal patterns, and that can go here. And so to start out, we've got the, say, starting positions, or let's say initial positions, and that is actually going to be a hash of A, and it can be in 1, 2, 3, 4, 5, 6, 7, 8. And I realized during the day that that calling these positions as their numbers, was it 1, 2, 3, 4, 5, 6, not 8, just 7. Calling by the numbers was kind of not a great solution. What I should have done is created keys for them, like top, left, right, middle, or top, top left, top right, middle, middle left, middle right, bottom. But actually, you know what? That I didn't realize that when I was thinking about it today, but I really, really like that. And am going to change it to handle that because I think that'll end up looking and feeling really nice to work with. And so let's double check that these are right. Yep. Top left, top right, middle, bottom left, bottom right, and bottom. And let's run 7-segment number spec, and it's all gonna fail because 7-segment number is this. So 1 is, actually let's do %s1 and replace it with top, except for that last one. So yep, no, %s2 is B, so it's top left. Yes, 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 no, yes, yes. %s3, top right. Yes, 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 no, yes, 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 yes. Okay. 4 is 1, 2, 3, 4 is middle. Yes, 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 no, yes. 5 is bottom left. Yes, 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 no. 6 is bottom right. Yes, no, yes, 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 yes. And then we do 7 is bottom. Yes, 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 no. Cool. So that'll, if I have bugs or as I'm writing this implementation, it's going to be a lot easier to just think about what is the position that I'm working with rather than number, and going back and forth. So we'll change this to available positions is top right, top left, middle, bottom. Oh no, it's not. Well, I guess it doesn't matter what numbers I have as symbols now, but did I do that wrong? Top left, no, okay. Top left, top right, middle, bottom left, bottom right, bottom. And actually, it didn't really matter what order I put these in because it since they're not numbers anymore. Actually, I guess the numbers didn't matter either, but since I'm going to be using them with symbols, I am really just going to be filtering out symbols rather than numbers or anything. So let's change this to B, C, D, E, F, A, B, C, D, E, F, G. Okay, and so those are the initial positions. Then we do while initial positions dot keys dot any key, or more values actually. Values dot any value dot length greater than 1. Let's make sure. Yep, okay. While any of these still have something in them, I need to, I'm going to loop through all of the given signal patterns that we started with, and figure out which. Oh, actually, I wonder if I messed this up. So the initial positions are there, and the 7 segment number is top. Yeah, no, I get that right. Okay, so what we'll do is just go through each of the signal patterns. So we'll do signal patterns dot each do pattern, and when we look at the pattern, we're going to count the number of characters, and then any of the we'll count the number of characters. The number of characters in it will determine what output, what 7 segment number it could possibly be, and then remove any of the other possibility, or any of the numbers that it couldn't be. So if we start with the simple case of AB, then we know that each of those A or B could only be in so AB, it means it can only be in top right or bottom right. And so we would remove any of the ones that it could be, but then also what we'd want to do is, see, maybe I'm getting ahead of myself here. So if I take the first pattern, I got A, C, E, D, G, F, B. So that's 1, 2, 3, 4, 5, 6, 7. The ones that have 7 are 1, 2, 3, 4, 5, 6. So only 8 is the one that has all 7. So that means it doesn't actually give us anything. We can't really do much with that. That doesn't help. Let's think here. How did we do it in Sudoku, if we know that these two are the only two, we can also exclude that from the other ones. So if we do the first one, we can't actually do anything yet. If we do the second one, C, D, F, B, E, then we know that there's 5, which is 1, 2, 3, 4, 5, meaning top, top, right, middle, bottom, left, bottom, or it's top, top, right, middle, bottom, right, bottom. And maybe breaking out, I got ahead of myself there with breaking out 7-segment number, because it would have helped to have, could have helped to have the possible numbers here. But I guess it doesn't matter. Let's see. Would it be best to sort them? Well, actually, I bet I can figure out what 7 is going to be by figuring out the 2 and the 2 and the 3. And is there always going to be a 2 and a 3? Let's look at the puzzle input and see. Yeah, I wonder if we can assume that it's going to be all the numbers. Let's see. Really, you might know that. Okay, so it is all 10 unique signal patterns. And so it's always going to be 10. So because of that, we know that I can figure out what the top is going to be. And so maybe I don't even have to loop through these. I can just do determine top. If I determine the top, I don't need to make these out into methods. It's going to be a big method, I guess. Let's say 2. Do I want to put these in length order? Or I can... Okay, so here I want to split by space, so I have a list of these. That would have been annoying to find out later. And then I want to I guess I can sort by item A, B, A, B, A dot length, B dot length, and then we'll do add signal patterns. Right, okay, so determine top is the first thing I know I can do. And that's because signal pattern sub 0 is the two segment pattern equals that, and 3 segment pattern equals signal pattern sub 1. And you know what, we maybe even map actually, can I do abc dot difference maybe? No. Nope. Okay. So the easiest thing here is to just map and split them. Pattern dot split on character. And then when we do that, we can do abc dot split on character dot difference ab dot split on character. Right, so C is the difference. And so that's how we know what the top pattern is going to be. So if we do 2 segment pattern, and actually does that work both ways? AB dot split dot difference, ABC dot split. No, okay, so I need to do the 3 segment pattern. I need to do the longer pattern first. Okay. So 3 segment pattern dot difference 2 segment pattern is going to give me the top segment equals that. And then what we can do is go here, do initial positions, sub top segment. Equals top, or I guess it doesn't, I don't need to do that. So, okay, so now we've got top and we've got at wire positions. Okay. And then, so we know that, and we know that the other 2 are either top right or top left, but we also want to remove top from all of the others. And so if we do 1, 2, 3 dot except 1, no, 1, 2, 3 dot methods minus object dot methods. Is there like an exclude or? Oh, actually I can get rid of that, huh? Now that we know it, we don't need to have it in there. Yeah, okay, so let's try that. Let's try removing it and see what happens. One, B, 2, A dot delete, A dot remove, see, clear, replace, empty. No, let's say drop chunk. No, wrong number of arguments given 0, expected 1. Is that a dot drop a? Does it just get a key? No, a dot delete a. Cool. So it is that it's key rather than the, well, square brackets. Okay, so just dot delete top segment, and then is it just, I think it's just initial positions dot each. Was it a dot? Oh, there's, I think, is there an each or an each? Each pair, each, yeah, maybe each pair. Value. Yeah, okay, cool. That's what I want it to do, and then I can just do initial position sub key equals value dot 1 2 3 4 a dot delete 4 a, yeah, okay, value dot delete top. And cool, so now we've removed top from all of the potential because we know what the top is going to be. We know 4 and we know 8 is going to be unique, but that's not going to help us. So now we can let's see, 1 4 7 8 were the unique ones. We can see, okay, so what's the next one that we can kind of explicitly determine here? So if we know A is gone, 4 is not going to have a top, but 4 is going to have a top left and a middle. 7, 1, and 0 don't have a middle. And so we can probably figure that one out pretty easily. Well, I guess what we can also do is remove top right and top left from, or no. We can figure out which ones are top left and top right and remove them. And so then we only need to find four would be top left and middle. Okay, well, maybe this path isn't going to be as lucrative as I thought it was going to be. Nothing's really jumping out at me as what something else is another number that I can know if I know top right, top right, and bottom right. Although I guess I can maybe determine middle if everything but 7, 0, and 1, I can determine what the middle is, then I can determine what top left is, because because 4 will be all filled out, and where B is, it won't be in anything else. So let's see if we can come up with an algorithm to figure out middle. The algorithm to figure out middle will be one, two, three, four, five, six. Maybe I can't actually figure out middle yet because there's another 6. So we got 2, 3, only one with 4. So we can remove the middle and left from everything. And if we do that, then we should be able to find let's see here. Wow, I'm really getting stopped up here. This is interesting. I can think of maybe I need to rethink this and do this where what I was going to do originally, where I'm looping through and just filtering out until everything is empty. thought it was nice to be able to find top right away, but it doesn't look like I'm going to be able to come up with a better way to do this. Yeah. Well, I wonder if I can determine 2 and 3. So I know that 7 and 1. I know 7. I know 4 because it's got 4. Actually, I guess if I just filter out through the other segments, I should get somewhere. If I just filter out the ones that it can't be. So if we do, let's say filter from top left and middle, because 4 is going to be 4 segment pattern at signal patterns sub 3, right? Because 2 segment pattern 2, 3, 4. No, that's actually going to be 2, 3, 4. It's actually going to be 2. So if we know the 4 segment patterns, what we can do is 4 segment pattern dot each do letter or do segment and initial positions dot each pair key value initial position sub key equals value dot delete oops, no, maybe initial positions dot each pair. Maybe let's see if I can start going to just had another idea. I wonder if there's something about the number of times a position shows up. I wonder if there's a unique set for that. So let's see. Bottom left shows up, well, let's see, top shows up 1, 2, 3, 4, 5, 6, 7, 8 times. Top left shows up 1, 2, 3, 4, 5, 6 times. Right, or top right is 1, 2, 3, 4, 5, 6, 7, 8 times. 7, 1, 2, 3, 4. So bottom left only shows up 4 times. And so what is, so that's the next lowest. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, bottom right. I can figure out bottom right immediately because it's the only character that doesn't show up in a 2. Okay. So I can determine determine bottom right. And so the way we'll do that is we'll do, we need to count the number of times each character shows up in the signal patterns. And so what we would do is, I think I can just do if I do results equals signal patterns dot reduce hash, and or let's say hash dot new 0 and key value. Can I do a reduce and a hash? A equals A1 B2 A dot reduce key. Yep, okay, I should be able to do that. And maybe what I should do here is, I kind of screwed up by doing this as a private method. It would have been nice to have this as a public method and be able to kind of test drive this. You'll have to remember to do that for future problems. I did that mostly through this puzzle, but for some reason chose to not do that at the end here, which is a bummer. But actually, I wonder if that's going to be patterns dot. Oh, that's actually not a. Right. So it's not a hash, so I can actually do this. So, and we do memo. Let's do iter dot each do end this is letter memo sub letter plus equals 1 and return memo. And let's see where we're at here. Let's make sure I did that right. Or segment decoder spec. Okay. Why did it just return there? So we should be calling decode test decoder decode. Segment decoder spec. I'm using the right file. Still in part 2. Okay. Maybe it didn't let me. Did it not get there, maybe? No, it's still there. It's not getting in there. What about up here? It got in there. Is it breaking out? Ah, that's why I have that return there. Okay. Okay, so what do we have for results? We have 8, 9, 8, 6. So here we know that B is 9, and that's for this one, is that going to be right? Segment decoder spec. Could be. Okay. But if we know that 9 is right, then we can, and we also know that G is 4, so G is going to be the only one with 4 there. So we can figure out two things here. What's the only other one with 4? No. Oh no, E is 4, and B is 9, and 9 is what? 4, 5, 6, 7, 8, 9. Okay, cool. So we know 9 and 4 are going to give us bottom right and bottom left, right? 1, 2, 3, 4. Okay, so all right, bottom left. And so that's going to give us let's say bottom right segment equals results dot select I think I can do a dot select where select value equals 1. Can I do that? A value equals 2. B equals 2. That's dot key. There's got to be there's a method to select by value, right? Well, it doesn't matter. I don't need to know the number. I just need to know the, so keys sub 0. Yeah, okay. Well, dot select key value equals 4. So when it's 4, we know that that's bottom left. So that's bottom. So 9 dot keys sub 0. And we can do bottom left segment equals results dot select key value equals 4, key sub 0 is going to give us that letter, and then we can do this. We can do initial positions dot delete bottom right segment, do initial positions dot delete bottom left segment, and then we can do at wire positions bottom right segment equals bottom right, at wire positions bottom left segment equals bottom left. And then let's remove those keys from the other ones to see what else we have left. Initial positions. Yeah, we can just delete bottom right from all of those and bottom left. And then, so now we have 3 of 7 figured out. We know bottom left and bottom right. And if we know bottom right, we can figure out top right, because that's the only thing that the 2 segment pattern should have left, right? Because if I've deleted those, then let's see, we should be able to determine top right, and let's put a pry here and double check that that assumption's right. Undefined method delete for top. Undefined method delete for top symbol. Is that line 51? No, 55. Why would that be? Top, 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 top. That's not right. Oh, wonder, well, not equals value dot delete top. We just want to value dot delete top. Does that change things? Yeah, okay. Or exit, and it'll get us to this next one. Oh. Okay, so let's get rid of this here. And we'll get rid of both of these. Well, okay, well, to do this, we need to take to determine the top right, we do 2 segment pattern dot each do segment. We do if or we can do initial positions dot keys dot select, let's say top right position equals initial keys dot select key dot 2 segment pattern dot include key And let's see what we have for top right position there. A, cool. Okay. So then what we do is we can do add wire position sub top right. It's not top right position, it's top right segment. Segment equals top right. And then we can do let's say change this to count results. And then once we have that, we can do the same thing from before. We can do initial position dot delete top right segment. Let's make it the same as the other ones, and then initial positions dot each pair key value dot delete top right, and that one's done. Let's see where we're at now. Then what do we have left? Exit. Why did that try not work? Undefined method results. Oh, right. Results. Count results. Cool. We've got initial positions, and there are 5 of them left, and only top left, middle, and bottom, only 3 left. So what did I do wrong here? Let's see, we've got 1, 2, 3, 4. So there should only be 3 available ones left. But the delete doesn't seem to be doing it. Why is that? Yeah. Bottom right segment, bottom left segment. B, C, D, F, G. Why would some of them not get deleted? Not each pair, value.delete, value.delete. Well, let's put a couple of pries in and see what happens. Don't have any weird returns in there anymore. And we got that last pry. Okay. Okay. Initial positions. Initial positions dot length 7. So we're removing top and going to remove right. Segment D, and D was not removed. Because it's an array. Huh. Okay. So top segment is not that, it's that. And then that's probably that as well. Let's double check that, but that should fix that bug. Cool. So now we know that there's top, left, middle, and bottom. We also know count results are that. We know that, let's say, count results dot delete E for 9, count results dot delete A for 4. We also know top right segment is B, count results dot delete B. Now we've got count results of 8, 7, 6, and 7. We're still missing one here. What's the other one that we got out of here? Is bottom right segment, bottom left segment. A, we know top right segment. B, oh right, top segment. So we can actually do the top segment is count results dot delete D, and then we've got count results of 7, 6, and 7. And so one of them is in there for 6 times. I actually think that 6 I probably could have figured out originally too, huh? 6 was the only one there. And then we only have 2 left. So that means yeah, so the original, I didn't think of that there's only going to be, is there only 1 6 here? Eight, 9, 8, 6, 7, 7, 4. Yeah, okay, so I missed one of these. So 6, something's in here 6 times. And it's going to be bottom, it's going to be top left, middle, or bottom. 1, 2, 3, 4, 5, 6, 7. Bottom is 1, 2, 3, 4, 5, 6, 7. And so top left is 1, 2, 3, 4, 5, 6. Cool. So we can actually remove one more. In this section, so top left segment is the one that's equal to 6. We can do this. Top left. And so now we end up with two left. We've got a middle and a bottom. And because we know that 4 has a middle but no bottom, we can figure out that one. Middle and bottom. Bottom, 46. Let's get rid of this pry. So we can determine middle by figuring out the 4th one again. Or I guess we never ended up doing that. Okay, so 4 segment pattern, signal patterns, sub 2, and then we do, we'll do something the same way that we did the same way we did the one above for top right. So it's top or middle segment equals initial positions dot keys dot select key for segment pattern dot include key, so 0. Remove that from initial positions dot delete middle segment wire positions sub middle segment equals middle, and initial actually don't even need to do that anymore. I can just do at wire positions sub bottom segment equals initial position sub, or no, let's do bottom segment equals initial position sub or dot keys sub 0, and then bottom segment equals bottom. Got rid of all the pries here, and I think the test should just pass now. Yeah, cool. So that was not a very clean way to do it, but it's a way nonetheless. Let's go here. Let's do 7 segment display is actually going to change a bit now because we've got a decoder, we've got a number, and then so we need to change the display to use the decoder. Display and a decoder, or I guess I can change the tests here. And what are we doing at the end? We are describe output value, do, and we don't need to pass anything in since we're passing in the display, but we do want to pass in a decoder. So require relative 7 segment, or what is it? Segment decoder. B and output value, let's say we know some of these. So for here, that first one is going to, that's FDG, yeah. Okay, so context sample 1. It is 8394. We do test decoder equals decoder dot, or segment decoder dot new. And we can do, I'm going to split that up in a second. Test segment display equals 7 segment display. Change this to new decoder. I don't want to change those other tests, so maybe I can do test segment display dot decoder equals test decoder, and then we would do test segment expect test segment display dot output value to equal 8394. Okay, here we do double quotes and take this half and cool. And so we're passing in a decoder that's going to give us the output value, and we can do another test here now that I've got this pattern better. Don't have to type it out. 9781, and we know that it's this. And up here we've got the second one here. Cool. 7-segment display. Cool. We've got two new errors. Undefined method decoder equals. What? Oh, right. Actually, I think I can just do adder, accessor, or adder. There's adder reader. Adder, is it accessor? Decoder. Right, and the undefined method output value. Cool. So now we have def output value, and the output value is going to be display.map digit or segments decoder. What's the API? I think it's decoder.decode, right? Right. Decoder.decode segments or pattern. Pattern. And once we do that, then we join. Just .join, right? Yeah, cool. And now let's just see what we got for the tests. We got 8394. Cool. So it's expecting. I didn't fix the expectation here, but it's fine for it to be a string now. But here it's not 8394. It's expecting 9781. 9781. And now those two pass. Cool. What if you get if you, oh, actually I don't want it to be a string. I want it to be, I actually do want it to be the number 9781 and 8394 because I need to add them together. Join to I. Cool. There we go. And now to the solution. If we do input line, we'll have patterns and what do we call display equals input line dot split on space pipe space, and we do require relative segment decoder. That'll be let's change the test input so we can verify that we've done everything right. This is display.output value. Or we can actually name it display. Let's name it display string. Display.output value is what we're adding together. We have a decoder equals segment decoder.new pattern or patterns. We do display.decoder equals decoder, and then we count them up, and we expect this to be 61,229. Ruby solution.rb 61229 looks good. And let's switch over to the puzzle input, and it's pretty quick. Let's see what we've got here. Whew. That one was surprisingly tough at the end. Fun to go through and see how to solve it when epiphany doesn't happen, but feels good to complete it either way. Learned a lot, and learned I need to do a little bit more looking into how. I'm curious to look up in Reddit and see how. See if there was something obvious that I didn't think of, but it's fun. Thanks for watching. Also glad I broke this into 2 parts because it's like it took me another hour to get here. Anyway, thanks for watching. I will be back tomorrow morning to see what problem 9 is. Thanks. Bye.